All right, so here's the picture. Marked it up a little bit. That's angle theta. Pulled out this big triangle here, did a little bit of Pythagorean theorem, and so we get that the angle is arctangent of 1/2, which is pretty evident without removing the triangle. Drew an extra radius here so that we get this isosceles triangle, so these two angles are the same. Up here is pi minus 2 theta, and of course the supplementary angle is 2 theta. We'll need that later. So the approach that I took was to find the area of the isosceles triangle, find the area of the sector over here, and then subtract those from the area of the triangle BAD, and that'll give us this area over here. Then look at this as a square minus this sector minus that piece, and it gives us the red. And if you do the math, it goes something like this. The area of triangle AOC, the isosceles triangle, is 1/2 times the product of its the adjacent sides to the angle times sine of the angle. Remember, the angle was pi minus 2 theta. Break out some trigonometry. Things collapse nicely. Thank you, pi. Double angle formula for sine. And we can get the values of sine of theta and cosine theta easily off of this triangle. And we get the area of the isosceles triangle is 32/5. Then to find the area of this sector, this pizza slice, that's pretty easy, just using proportions, because the central angle cutting off that was 2 theta. And so it's 2 theta divided by 2 pi times the area of the circle, pi r squared. And that cleans up to 16 arctangent of 1/2. I'm not sure if I ever actually mentioned that, but theta is arctangent of 1/2. So this gives us the area of this slice. And so now we can find the area of this little white wedge over here by taking this triangle and subtracting the two areas we found. I called that wedge BCD. So the area of BCD is the area of the triangle, the big triangle, BAD. Where'd it go? There it is. 1/2 times 4 times 8 minus 32/5, which is the area of the isosceles triangle AOC. Minus 16 arctangent 1/2, which was the area of the sector. And so what that represents, once you clean it up, 48/5 minus 16 arctangent 1/2, that represents this area here. And now we take another perspective and we think of this as a square. And to find the red area, we just have to take the square minus this quarter circle minus that piece. That's pretty straightforward. The area of the square is 16. The area of the quarter circle is 1/4 the area of the circle, so 4 pi. And so the area of DCE, which is the area that we're looking for, is the square minus the quarter circle minus BCD, this piece that we found earlier, which was 48 minus 16 arctangent of 1/2. And so do the math, you get 32/5 minus 4 pi plus 16 arctangent of 1/2. If you want to be cute, you can factor out a 4/5.